So we got problem number 6. Okay, this one is a good one. Okay, so incline problem. These are standard physics problems. All right, so here's your incline. Boom, here's an incline. Okay, so what do we have? I got my incline. So there's going to be a 50-pound mass placed on an incline. So it's going to be, this is the angle. So that's going to be 30 degrees. It's a 30-degree incline. So that's what it is. It's going to remain motionless. So you place the mass here, it's not going to be moving. So determine the value of the static frictional force and the normal force acting on this mass. All right, so I'm going to place a mass right here. All right, so this is the mass. And then I'm going to place my coordinate system on top of it. Okay. Traditionally, we would place the x-axis parallel to the surface. Okay, well, that just was too cute. Okay, so I'm going to place the x-axis parallel to the surface. Don't go. Cool. All right, so x-axis is going to be in this direction. And the y-axis is going to go up. Okay, so I got my x and the y coordinate system. Okay, the next thing I'm going to do is I'm going to place my forces. All right, so center mass is going to be located right here. All right, so it's got weight in the downward direction. Okay, so it's sitting here on top of this surface, right? So which means that it's going to experience a normal force in this direction. So the normal force is going to be going up in this direction. All right, so obviously it's trying, because of gravity, it would normally slide in this direction, but it's not able to slide in that direction. So this motion in this direction is going to be counteracted by the frictional force in this direction. So static frictional force is going to be acting on it in that direction. So static frictional force is going to be acting on it in that direction. Okay, so we got everything that we need, I think. So what do we do? Okay, so the mass is going to be 50 pounds. Angle is 30 degrees. Okay, so it's motionless. Okay, so which means that the acceleration is going to be 0. Along the x direction, along the y direction, regardless, there's no acceleration in this case. Okay, so what do we need? It says determine the value for the static frictional force and the normal force. Okay, so we need to figure out this and that. So the frictional force, we want this in terms of newtons and then figure it out in terms of pounds. And then we also have the normal force. Once again, let's figure that out. Okay, so we got 2 unknowns. All right, so before we go any further, let me put the angle here. And I think I want to change color. Okay, so here's the angle. Okay, so this angle over here is going to be the angle over there. Okay, convince yourselves that that's correct. I don't know how you will do it, but just convince yourselves that I know what I'm doing. Okay, because for whatever reason, I can see this sort of stuff, but explaining math is not my forte. Okay, especially something related to geometry or whatever. Okay, so all right, so it's identical triangle. So this angle is the same as this angle here. That's the only contribution that I will have in the way of mathematics right now. Okay, so that's what we got. So what do we do? Okay, once again, we got 2 unknowns. Okay, so which means that we will need 2 equations to solve this problem. All right, so what I'm going to do is I'm just going to grab this shape. Ooh, okay, I killed it. I'm going to grab this portion. And then I'll take a look at the forces on it. Okay, so now let's take a look at the net force on the x direction. Okay, so what do we have along the x direction? Along the x direction, you have the static frictional force. Okay, guys, this direction is positive. Opposite direction is going to be negative. So this one is going to be a negative force. Static frictional force. Okay, what else? All right, notice that the weight has a component along this direction. So this is the x component of this weight. So the x component of this weight is going to be W times cosine. It's going to be sine of the angle, right? All right, so this component is pointing along the positive x direction. So which means that it's going to be plus. It's going to be W. It's opposite. So it's going to be sine of the angle. And obviously mass times acceleration along the x direction. We know that the acceleration is 0. We know that the acceleration is 0 because it's a static case. Okay, so we're done. All right, so that's our first equation. All right, this equals to 0. So what I can do is just add this to both sides. And then I can reverse sides, whatever. So this is going to be W sine of theta. W is the same as mg, so let's just keep it like that. Okay, that's it. Okay, so question is, do we know m? We certainly do. Do we know g? Yes, we do. Do we know the angle? Yes, we do. So this thing is solved. Okay, so before we move forward, okay, so this is a complete solution. Except there's a slight problem. The problem is we didn't do the conversion, so this would give us the wrong answer. Okay, so what is that in terms of kilograms?
22.72.
22.72, give yourself 5 points. Okay, now we're good. Okay, so I'm getting my acceleration in. Okay, so if you have the number, give me the number in terms of newtons. All right, so static frictional force.
113.6.
113.6. So that's newtons. Okay, that's good. All right, so what is this in terms of pounds?
Roughly 25 pounds.
Roughly 25. Okay, give yourself 5 points. Okay, good. All right, so let me think about it. Okay, so it's 50 pounds of weight. So the static frictional force is going to be 25. Okay, it's reasonable. Okay, so we took care of one of them. The next one is the normal force. Normal force is on the y direction. All right, so let's take care of that. So let's take a look at the net force on the y direction. All right, so what do we know? So n is in the upward direction. So this one is positive. W is in the downward direction, and W has a component on this direction. So the component of W is going to be the cosine of the angle, right? All right, so n is up. W is down. W is the same as mg. It's going to be the cosine of that angle. All right, so there's no acceleration on the y direction. Okay, so that term goes to 0. So what do we have? So now we got n equaling mg times the cosine of the angle. Okay, this wasn't that bad. This was a good exercise, though. All right, so at least you guys know how to resolve these forces. Two unknowns, which means you have to have 2 equations. Okay, so boom, we're done. That's the final equation. Okay, so whenever you're done, just give me the number.
196.76 newtons.
Okay, so give yourself 5 points for that one. That seems reasonable. Okay, very good. And in terms of pounds?
43.28.
28, so that's about 43 pounds, right? Okay, not bad. Okay, so once again, the emphasis is you got 2 unknowns. You need 2 equations. Boom, these are the 2 equations that you get to use. All right, so if you got 2 unknowns, this is one equation. This is the second equation. Okay, so now you know how to generate these equations. Okay, so